have seen the empirical and molecular formulae. Empirical formula comes from experience or from experiments. It gives the ratio of the different elements present in the compound. And the molecular formula represents the actual formula of the compound. Let's look at a few questions to derive the empirical and molecular formulae. We have a compound made of carbon, hydrogen and bromine, and this compound is used as a pesticide in soil and on various crops. The percentages of the different constituents are carbon percentage is 12.67, hydrogen 2.13% and bromine 85.11%. The vapor density of the compound is 94, so we have to find the molecular formula of the compound. So let's start. First of all, we have to look at the three elements which are present. So we have carbon, hydrogen and bromine. Now let's check their percentage compositions. So we have carbon 12.67% in the compound, hydrogen is 2.13% and bromine is 85.11%. So these are the different percentages of the three elements. Now we know the atomic mass of carbon is 12. The atomic mass of hydrogen is 1 and of bromine is 80, which is also given to us. Now this is the percentage composition of carbon in the compound and this is the atomic mass of carbon. So when we divide this number, that is 12.67, which is its percentage composition, by its atomic mass, we get its atomic ratio. Similarly, to get the atomic ratio of hydrogen, we divide its percentage composition by its atomic mass. Similarly for bromine, so now we get the atomic ratio of the three elements present in the compound. So these are the three atomic ratios. The atomic ratio of carbon is 1.06, hydrogen is 2.13 and for bromine it is 1.06. Now when we are looking at the atomic ratio, we want the simple whole number ratio. So to get the simplest whole number ratio from these numbers, we divide all these numbers by the smallest of the three. So in this case, we observe that out of 1.06, 2.13 and again 1.06, 1.06 is the smallest. So we divide all the three by 1.06. So to get the simplest whole number ratio, since these decimal points do not give us the simplest whole number ratio, so we divide all these numbers by the smallest number. So we get 1 for carbon, 2 for hydrogen and 1 for bromine. So this is the simplest whole number ratio in which the three elements are present with respect to one another. So from these ratios, we get the empirical formula of the compound. So we get the empirical formula of the compound to be CH2Br. As we had seen, the simplest ratio for carbon was 1, for hydrogen it is 2, and for bromine it is 1. So whenever we have 1, we can ignore it. So the empirical formula of the compound is CH2Br. Now we calculate its empirical formula weight. So the atomic mass of carbon is 12. Atomic mass of each hydrogen atom is 1. So for 2 we get 2. Similarly, atomic mass of bromine is 80. So when we calculate from the empirical formula weight, we get 94 atomic mass unit. Now, we know that the molecular weight of any compound can be calculated by doubling its vapor density. So the molecular weight is twice the vapor density. In the question, we are given that the vapor density of the compound is 94. So from this, we can get the molecular weight of the compound. So the molecular weight becomes 2 times the vapor density, that is 2 times 94. And we have already calculated the empirical formula weight. So we now know that the empirical formula weight from the formula CH2Br is 94, and the molecular weight we can leave it in this form itself, that is 2 into 94 atomic mass unit. Now we calculate the factor. The factor, that is the molecular formula weight divided by the empirical formula weight. So when we calculate this, we get 2. The 94 and 94 gets cancelled and we get 2. So now the empirical formula was CH2Br. The molecular formula becomes the entire empirical formula into 2. And this is the factor n that we had calculated. So now our actual formula or our molecular formula becomes 2 into 1 C2, 2 into 2 4 H4, and 1 into 2 2. So this becomes our actual formula or our molecular formula. And this is the compound which is used as a pesticide. So the empirical formula of the compound, it's CH2Br. This gives the ratio of the different elements present in the compound, and the actual or the molecular formula of the compound is C2H4Br2. Let's look at another example here. We have a compound of lead, nitrogen and oxygen, and this compound is used in match manufacturing and as an explosive. The different percentages of the elements are: lead is present as 62.5% in the compound, nitrogen is 8.5%, and oxygen is 29%. We are given the relative atomic masses of the three elements, and we have to find out the empirical formula of the compound. So let's start. First of all, the three elements that are present in the compound, there is lead, nitrogen and oxygen. These are the three elements which are present in the compound. Now we look for the percentage compositions. So lead is 62.5%, nitrogen is 8.5%, and oxygen is 29% in the compound. Now let's write their atomic masses. So the atomic mass of lead given to us is 207. For nitrogen it is 14. And for oxygen it is 16. Now to find the atomic ratio of each of the elements in the compound, we divide the percentage composition by the atomic mass. So for lead we get 62.5 divided by 207. The atomic ratio of nitrogen is 8.5 divided by 14, and the atomic ratio of oxygen is 29 divided by 16. So these values, that is when we divide 62.5 by 207, we get 0.301. Similarly for nitrogen we get 0.607, and for oxygen we get 1.81. So these values give us the atomic ratio of the three elements, that is lead, nitrogen and oxygen in the compound. But again we see that these are not the simplest ratios, that is the simplest whole number ratios. So to find the simplest whole number ratios, we look at the smallest number out of the three. So in this case we see that 0.301 is the smallest. So we divide the three numbers by 0.301. Now we also do not have to be very accurate. That is, we at times take the approximate value. So we can also use 0.3 for these calculations. So we take this as 0.3. So this becomes the smallest value, and we divide it by 0.3. So to get the simplest whole number ratio, we can also use the approximate method. We can take this as 0.6. We divide it by the smallest number, that is 0.3, and we can take this as 1.8. So when we do this, we get the simplest whole number ratios of the three elements. So for lead, we get 1. For nitrogen, we get 2. And for oxygen, we get 6. So these are the ratios in which the three elements lead, nitrogen and oxygen are present in the compound. So from this simplest whole number ratio, we can get the empirical formula. So we get the empirical formula to be PbN2O6. Since we have not written anything as the subscript here, it shows that the number is 1. So this is the empirical formula of the compound. Once you start using more and more elements and compounds, you will see that this exactly is not the formula of a compound. Instead, there is a radical NO3 that is actually present. So we have lead and 2 radicals of nitrate. So when you see this formula, you again see there is 1 lead, there are 2 nitrogen atoms, and there are 6 oxygen atoms. Don't worry, once you start using these compounds again and again, you'll get the hang of how we get these elements and compounds. So PbN2O6 is not exactly the empirical formula of the compound. Instead, the compound that is used for match manufacturing and explosives is lead nitrate. That is PbNO3 whole twice. So remember that this factor N, which is the molecular weight divided by the empirical formula weight, this gives us the exact or the actual formula. So when we multiply the empirical formula by this factor N, we get the exact molecular formula or the actual formula of the compound. And also remember that twice into the relative vapor density is the relative molecular mass of the gas or any compound. So 2 times the relative vapor density gives us the molecular weight of the compound.